Hey guys, so classmate asked, how do you find the equation of the line tangent to r equals 1 plus cosine theta at theta equals pi over 6? To actually solve for our tangent line, we would first need to find its slope. Remembering that the slope of our tangent line is just the derivative of our original function at the given point, pi over 6, we need to find dy over dx. To start off, we have to change the polar equation into a pair of parametric equations so that we can see it in terms of x and y. Remembering that x equals r cosine theta and y equals r sine theta, we plug in our polar equation into the variable r. So that x equals cosine theta all times 1 plus cosine theta, and y equals sine theta all times 1 plus cosine theta. Now, let's find the derivative of each equation. To find dx over d theta, we will use our product rule, in which cosine theta will be our u and 1 plus cosine theta will be our v. Following our equation u dv plus v du, we get dx over d theta equaling cosine theta times negative sine theta plus 1 plus cosine theta times negative sine theta. If we simplify further by distributing and combining like terms, dx over d theta equals negative 2 sine theta times cosine theta minus sine theta. We will follow the same procedures for finding the derivative of dy over d theta. Since y equals sine theta times 1 plus cosine theta, sine theta will be our u and 1 plus cosine theta will be our v. Solving for dy over d theta, we get sine theta times negative sine theta plus 1 plus cosine theta times cosine theta. If we simplify further by distributing and rearranging terms, we get dy over d theta equals cosine theta plus cosine theta squared minus sine theta squared. Having both dy over d theta and dx over d theta, if we divide those two derivatives by each other, we get dy over dx. Therefore, we will divide cosine theta plus cosine theta squared minus sine theta squared over negative sine theta minus 2 sine theta times cosine theta. If we remember our trigonometric identities, we can simplify this equation further. Since sine 2 theta equals 2 sine theta times cosine theta, and cosine 2 theta equals cosine theta squared minus sine theta squared, we can plug this back into our original equation. So that dy over dx equals cosine theta plus cosine 2 theta all over negative sine theta minus sine 2 theta. To actually solve for our tangent line, we need to find the numerical value of our slope. So we'll substitute in pi over 6 for every instance of theta, since that's the initial condition stated within our problem. Remembering that pi over 6 is the radian form of 30 degrees, we get our slope equaling square root of 3 over 2 plus 1/2 all over negative 1/2 minus square root of 3 over 2. If we simplify our equation further, we see that our slope is actually just negative 1, with the numerator and denominator having the same terms but with flipped signs, showing that if we divide each by the other, we get negative 1. Now that we have the slope of our tangent line, we need to solve for our y-intercept. To do so, we first have to solve for what y and x equals at our point of tangency, or pi over 6. Using our parametricized equations, we plug in 30 for every instance of theta. So that x equals 1 plus square root of 3 over 2 times square root of 3 over 2, and y equals 1 plus square root of 3 over 2 times 1/2. The decimal value form of these points is approximately 1.616 for x and 0.933 for y. Plugging in the x and y values that we calculated for back into the tangent line equation, we get b equaling 2.549. So our final equation of the tangent line is y equals negative x plus 2.549, with a graph looking like this, a tangent line touching the side of our polar curve, which is a chordioid. I hope this video helped you to understand how to find the slopes of polar curves and their tangent lines.